When dealing with electric heated forced air delivery systems, it's important to adhere to the relevant underwriters' laboratories, or UL, standards to ensure safety and proper functionality. The primary standard directly applicable to electric heaters used in duct systems is UL 595, which specifically addresses electric heaters intended for use in duct systems. Additionally, UL 1996, the standard for heating and cooling equipment, provides broader guidelines that can be relevant to these systems. UL 2021, the standard for low-voltage electrical equipment for use in heating, ventilation, and air conditioning, or HVAC, systems, is also a good resource. Furthermore, UL 873 covers safety temperature controls, which are essential for regulating the temperature of electric heaters and preventing overheating. Beyond these core standards, several other UL standards may be relevant depending on the specific application and components used in the electric heated forced air delivery system. UL 508. A. The standard for industrial control panels applies if the system incorporates a control panel. UL 1995 addresses safety controls for refrigeration systems and may be relevant if the system integrates refrigeration components. UL 3690 covers electric central air heating equipment, offering insights into the requirements for central heating systems. For portable electric heaters, UL 650 provides specific guidelines. UL 1025 applies to electric air heaters, providing standards for their construction and safety. If the system uses electric infrared heaters, UL 1256 is the relevant standard. Electric fan heaters are covered by UL 1747. For appliances that incorporate heating elements, such as electric ovens and ranges, UL 1811 is applicable. UL 2207 covers electric dishwashers, UL 2208 covers electric clothes dryers, and UL 2211 covers electric heat pumps. Firstly, it is important to consult the scope of each standard to determine its applicability to your specific system. The scope outlines the types of equipment and systems covered by the standard, as well as any limitations or exclusions. Secondly, review the requirements outlined in each standard, paying close attention to the electrical safety requirements such as wiring methods, overcurrent protection, and grounding. Thirdly, ensure that all components used in the system are UL listed or recognized, meaning that they have been tested and certified by UL to meet the applicable safety standards. Fourthly, consider the environmental conditions in which the system will be installed, such as temperature, humidity, and exposure to corrosive substances. Select components and materials that are suitable for these conditions. Fifthly, ensure that the system is installed in accordance with the manufacturer's instructions and all applicable codes and regulations, including the National Electrical Code, or NEC. Sixthly, verify the ampacity of the conductors. According to the NEC, specifically Article 310.15, conductors must be sized to carry the anticipated load. Table 310.15. B16 allows you to look up the ampacity of various conductors based on their insulation type and temperature rating. For example, a 12 American wire gauge, or AUG, copper conductor with THHN insulation rated for 90 degrees Celsius typically has an ampacity of 30 amps, but this can vary depending on the specific conditions of the installation. Seventhly, select the correct overcurrent protection. Circuit breakers or fuses protect the conductors and equipment from overloads and short circuits. NEC Section 240.4 dictates the requirements for overcurrent protection. Generally, the overcurrent device should be sized to protect the conductor's ampacity. For example, a 14 AWG copper conductor with an ampacity of 15 amps typically requires a 15 amp circuit breaker. However, there are exceptions, such as the tap rule, which allows for smaller conductors to be used in certain situations. Eighthly, regarding grounding and bonding, all non-current carrying metal parts of the electrical system must be properly grounded and bonded to provide a path for fault current to return to the source. NEC Article 250 provides detailed requirements for grounding and bonding. Grounding ensures that in the event of a fault, the circuit breaker will trip, de-energizing the circuit and preventing electrical shock. Bonding connects all metal parts together to create an equipotential plane, minimizing voltage differences and reducing the risk of electric shock. Ninthly, consider voltage drop. Excessive voltage drop can cause equipment to malfunction or fail prematurely. In EC Article 210.19, A1. Informational note number 4 recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using Ohm's law and depends on the conductor size, length, and current. Using larger conductors can reduce voltage drop. Tenthly, check for proper wiring methods. The NEC specifies approved wiring methods for different types of installations. Common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheath cable, or ROMICs. Each wiring method has its own set of requirements for installation and support. Make sure the wiring method is appropriate for the environment and application. These UL standards and NEC regulations play a vital role in ensuring the safety and reliability of electric heated forced air delivery systems. Therefore, it is crucial to carefully review the applicable standards and regulations and to implement appropriate safety measures to protect personnel and property.